So now we start the displacement of the fringe by inserting the glass slab in front of the YDSE experiment. Right. You may write displacement of fringes. Right. Displacement of fringes by insertion glass slab in front of slits, right, in front of slit. For example, suppose we have, this is the YDSE, this is the S1, this is the S2, and the light is coming from left. So you will see the dark fringe, bright fringe, bright fringe, dark fringe, bright fringe, dark fringe, like that. Understood, Sanjay? Right. But what happens if we insert a glass slab in front of one slits? Suppose the thickness of the glass slab is T, right, and the refractive index is mu. Are you getting or not? I'm giving you the concept. Listen one thing. If this is the glass slab of thickness T, the refractive index mu, when light goes in this, right, so its geometrical distance covered. Geometrical distance mean what we see, what we can measure by the scale. Geometric distance traveled by the light is T, and the optical distance is how much? It is mu into T. Are you getting or not? The optical distance, what does it mean? It means if light is traveling, the speed become low, speed become less in the in this glass slab. Are you getting or not? Till this point, suppose this is the thickness T, till this point the light come together. Suppose these are the two light rays coming from infinity. So the speed is reduced, but the speed of the light in the air remains same. So it cover less distance geometrically, but it cover the more distance. And this distance if mu, so this is the distance covered by the light in the air is mu T. So by seeing or by measuring this distance, geometrical distance is T, but we will consider the distance covered by the light is equal to mu into T, because its speed is reduced by the mu times over here. In this case, what is the speed? The speed is C by mu, where the speed of this light ray in this case is only C. Are you getting? So it cover more distance. So I will take the distance covered, the optical path is nothing but mu T, equivalent to the path covered in the glass slab. You understand or not? Right? Yes, copy this first. Okay, when the light comes, right, in the form of the plane wave front like this, so the light, if you consider any point on the screen, suppose this is the same screen at the distance d over there, right, so one light reaches from his and one light reaches from this, right, this is S1, this is S2 and point P. Are you getting or not? So this thickness is T. So what is the path difference, you will say now? What is the path difference? Path difference you have to find. Are you getting or not? What is the path difference, you will say? Listen, one light is coming from S1 and then other is S2. This, suppose this is the X2, this is the X1, right? So the path difference is X2 minus. If it was, listen one thing, if it was the air, it is X1 and X2. Here the path difference was X2 minus X1, right? Path difference is nothing but X2 minus X1. But here the distance traveled by this wave, right? What is the distance covered in the air? In air, the distance covered is X1 minus T. So this is the distance covered in the air is x1 minus t. Understood? And the distance covered in the glass slab is t. So its equivalent path is mu t. You understand this thing or not? This is the path travel in the air. This is the path travel in the glass slab. Do you understand this? So x2 minus x1 plus t minus mu t. So this is equal to what? Delta x plus plus, or you take minus t common, mu minus 1. So this is the path difference. So listen one thing. This is the path difference, x2 minus x1. And what is the, if this is the angle theta and this is d, are you getting? So this path difference delta x, geometrically delta x is equal to what? Say d sine theta. If this is d, this is theta, it comes to be d sine theta. So I will put its value is equal to d sine theta minus t mu minus 1. So when the glass slab is inserted, the path difference is d sine t minus t mu, right? This is the path difference. All right. This is the calculation of the path difference when the glass slab of thickness t is placed in front of one of the slits. Copy this. So in this case, at this point, which is, this is the central bright fringe and this is the distance y, this is the distance d. Again by geometry, if this angle we assume to be the theta and this angle is to be assumed theta, right? This is d, so this distance is nothing but d sine theta, right? We have always calculated. This delta x is nothing but d sine theta. The path difference now for constructive interference, what is the condition for the constructive interference or bright fringe? We are going to find the position of bright fringe from the central bright fringe, bright fringes, right? Bright fringes. So for constructive interference, path difference must be equal to what? You tell, say n lambda. Are you getting or not? So this is d sine theta minus t mu minus 1 into d. So the d sine theta will equal to, right, n lambda plus t into mu minus 1. If the theta is small, the sine theta is equal to what? Say tan theta, and tan theta is nothing but y upon d is equal to n lambda plus t mu minus 1. So y is equal to n d lambda over d plus d upon d mu minus 1 into t. So this is the position of nth bright fringe. What is it? Position of nth bright fringe from center. Is it clear? Copy this. So listen one more thing. So where the n is equal to 0, listen one thing. This is the central bright fringe, CBF initially, before inserting any glass slab. All right. So first the position of the central bright fringe. For position of CBF, what is the condition we should have? Tell me, what is the condition of central bright fringe? The condition of central bright fringe is path difference must be equal to 0. Are you getting or not? Or you can say the n is equal to 0, you can say, right? If the path difference is 0, right, what does it mean? 0 is equal to d sine theta minus t mu minus 1 into d. So d sine theta is equal to t mu minus 1. Sine theta is what? Tan theta is equal to y upon d is equal to t mu minus 1. So y is equal to d upon d mu minus 1 into t. So this is the position of central bright fringe. Now listen one thing. What does it mean? I'm making the figure over here. You can make the figure this side. Listen, although if it is the central bright fringe, but when you insert the glass slab in front of one of its, right, slits, so this fringe pattern shifted in the in this direction where the glass slab is put. So the central bright fringe from here it reaches to this point. This is the central bright fringe. What does it mean, central bright fringe? Here the light reaching at these 2 points, the path difference, this and this, the path followed is same. So what is the distance? This is the center now, it is the center, and this is the center bright fringe. And what is the shift in the central bright fringe? This is called also the shift, right? The shift is d upon d, mu minus 1 into t. Are you getting or not? This, what does it call? This is the shift in the fringe pattern. Shift in the fringe pattern, right? Listen one thing, pattern, one thing. This is the d1, this is the d2. Now this is the central bright fringe, and it is the d1 now. It is the b1. It is the d2. It is the b2. This is the central bright fringe. This is the dark. This is the bright. This is the dark. This is the bright, like this, right? So this is the central bright fringe. Now it become d1. It become d2. It become b1. It become b2. Do you understand or not? So all the fringe pattern is shifted in the same direction as the glass slab is placed. Do you understand or not? And what is the shift? The shift you may write d upon d, mu minus 1 into t. So this is the shift in the fringe pattern. Sometimes along this value is asked in many questions. Copy this. So this is the position of the central bright fringe from the center. Now this can also be found by putting n is equal to 0 over here, right? So y is equal to, if you put 0, d upon d, mu minus 1 into t, you can find this also, right? This is the central bright fringe position. Although the by putting the path difference equal to 0, we can also find this same relation. Now we are finding the position of the bright fringes. So if this is the central bright fringe, this is the v1. So this is the y1. How to find? Put n is equal to 1 in this expression, because this is the position of nth bright fringe. So y1 will be equal to d lambda over d plus d upon d mu minus 1 into t. N is equal to 2, y2 is equal to 2d lambda over d plus d upon d mu minus 1 into t. N is equal to 3, 3d lambda over d plus d upon d mu minus 1 into t. Yes, listen one thing. This is the y1. Suppose this is the b1. So what is this? This, how much distance this? This distance was d lambda over d. For b2, what is the distance? Say 2d lambda over d in normal YDSE. But when the glass slab is inserted, so what is the distance of y? This is the distance of y1 from the center. What is that? Y1 is equal to this distance plus how much it is? You tell. It is equal to d lambda over d, because this is the beta. What is the distance of the b2 from the center? This is the y2. Y2, this is the beta, this is the shift, plus one more beta is over there. You are getting the figure, Sanjay? Copy this. In the same way, this is the basic path difference, right? And we can find the position of the destructive interference, right? So I'm writing the position of dark fringes. What does it mean? Position of dark fringes mean destructive interference, right? So if this is the path difference, the path difference must be equal to what? It should be equal to 2n minus 1 lambda by 2, and by geometry the path difference come to d sin theta minus t mu minus 1. So d sin theta is nothing but equal to 2n minus 1 lambda by 2 plus t into mu minus 1. D sin theta is d tan theta. This is y upon d is equal to 2n minus 1 t mu minus 1. Yn is equal to d lambda over 2d, right, plus d upon d mu minus 1 into t. Is it clear or not? Like this, where the n you can put 1, 2, 3, right? So by putting these value, we can find the position of dark fringe. Dark fringe mean d1, position mean not from the central bright fringe, it is from the center, right? You will see the y1 is equal to what? Say d lambda over 2d plus d upon d mu minus 1 into t. Y2 is equal to what? When you put n is equal to 2, 3d lambda over d about 2d divided by d plus d mu minus 1 into t. Y3 is equal to 5 by 2 d lambda over 2d, 5 d lambda over 2d plus d upon d mu minus 1 into t. Is it clear or not? So this is for the position dark d1, d2 and d3, but from center, not from central bright fringe. This is the central bright fringe. Copy this. Okay, so now can you tell me, this is the all the fringe pattern is shifted in this direction only, right? Can you tell me what is the fringe width? Fringe width in this case, the fringe width beta remains same, right? It is same. How much? It is d lambda over d. How it is? Because the fringe width is defined as the difference between the distance between the two consecutive either bright fringes or the dark fringes. When you subtract this from this, you will get, it will cancel out 2d lambda over d minus d lambda over d. So it remains same. It does not change. Does not change. The fringe width does not change. Are you getting or not? Yes. So this is the concept of the inserting the insertion, the glass slab in front of the slab, in front of the slit. For example, now if we have the two slits S1 and S2, right? This is the glass slab of thickness T1, mu1. Because of this, the fringe pattern is shifted in the upward direction, in the upward. If you another glass slab is put in front of S2, right, of thickness T2, and this is the mu2. Due to this, the fringe pattern will be shifted downward. Are you getting or not? So in this case, net shift will be equal to what? Net shift is equal to d upon d mu1 minus t1. This is the positive, you can take this is the positive shift, and this is the negative shift, d upon d mu2 minus 1 t2. This is the net shift in the fringe pattern, in the fringe pattern. Do you understand or not? Okay, listen one more thing. If this is the shift by first slab, this is the shift by second slab. If the condition if fringe pattern does not shift, what does it mean? Then that is net shift is what? Net shift is 0. So net shift is 0 mean d upon d mu1 minus t1 d upon d mu2 minus 1 into t2 is equal to 0. When you will simplify this, mu1 minus t1 is equal to mu2 minus 1 into t2. D upon d will cancel out. So what the relation you will write? T1 upon t2 is equal to mu2 minus mu1. So this is the condition for the net shift to be 0, right? Copy this. So we can do some question based upon this, right? For example, listen. For example, I'm writing in short. The wavelength of the light is used is 600 nanometer in YDSE, and the glass slab thickness is given in the question, and this is T is equal to 1.8 into 10 ki power minus 5 meter, and refractive index is 1.6. Then by placing this, right, then how many fringes will be shifted by putting this glass slab in front of one slit, right? Yes, copy this. Listen one thing. When the glass slab is put, without glass slab, center bright fringe is over here. Are you getting or not? But if you put the glass slab, the center bright fringe shifted to this point or not? You tell. So what is the shift? You tell. Shift is nothing but d upon d mu minus 1 into t. Are you getting or not? Sanjay? Hello? So what they are asking, how many fringe will be shifted? Or they can also ask how many fringes crosses the center of the screen. So there will be, this is the central bright fringe, this is the dark fringe, this is the CBF, this is the bright fringe, dark fringe, bright fringe, dark fringe, like this. Are you getting or not? So if you are found the shift, for example, this is the 10 centimeter. Are you getting or not? And the fringe width is 2 centimeter. Is it clear or not? So how many fringes are shifted? Can you tell? Yes, the shift 10 upon 2, number of fringes shifted will be 5 in this case. What does it mean? Fringe width is nothing but beta is equal to d lambda over d. So number of fringes shifted or crossing the center, how many number of fringes will be over shift divided by fringe width. So it is equal to mu minus 1 t upon lambda. So this is the solution, right? So now we can find the answer, right? For example, n will be equal to mu minus 1 lambda into t. So mu is 1.6 minus 1. The wavelength is 600 nanometer and the thickness is what? 1.8 into 10 to the power minus 5. 0.6 into 6 into 10 to the power minus 7. 1.8 into 10 to the power minus 5. So this is 18 upon 6. It will come, right? So 3. So how many fringes are shifted? Oh, it is coming wrong. Divided by 6.6. Wait for 1 minute. This is 6 into 18 upon 6. So number of fringes shifted will be 18 in this case, right? Copy this. So this is in this question, right? What we have, wait for 1 minute. Okay, so in this question what we have a YDSE experiment. In place of one slit, the paper of the thickness T, and what is the thickness T? 0.02 millimeter is spaced. The refractive index is 1.45 in front of S1 and S2, right? And pasted across, the paper transmit the intensity 4 upon, suppose this is the intensity I naught, it was the intensity I naught, but when it passes this paper, the intensity become 4 upon 9 I naught. You understand or not? So what they are asking in the first part, they are asking the Imax and Imin ratio. Do you understand or not? Can you find this? Yes, we can find. How to find the Imax? Root I1 plus root I2 upon root I1 minus root I2 whole square. Is it clear or not? So after putting the paper in front of the slit, so it become I1 suppose, and it become I2. Initially the intensity was same, but after placing the paper the intensity is reduced to the 4/9 times of the initial. So it is root over 4/9 I naught plus I naught divided by 4/9 I naught minus I naught whole square. It is 2/3 plus 1, 2/3 minus 1 whole square. Alright, so it is 5/-1 whole square, 25 upon it. So the Imax upon Imin ratio is nothing but equal to 25/1. Copy this. In this case, in the second part, number of fringes shifted you have to find. So what is the number of fringes shifted formula? I told you. This is the total shift divided by fringe width. So I think you should remember in this way. Is it clear or not? So mu is 1.45 minus 1 into t. Thickness is 0.02 into 10 to the power minus 3. And what is the wavelength? The wavelength given is 600 nanometer. So it is 600 into 10 to the power minus 3. 0.45 upon 0.6 into 2 into 10 to the power minus 5. 0.9 upon 0.3, 0.6, right, into 10 to the power minus 5. 3/2 into 10 to the power minus 0.9. Wait for 1 minute. How many shifts are there? It is 600 nanometer. Now it is fine. 0.45 into 2 into 10 to the power minus 5, 6 into 10 to the power minus 7, right? So 90/6. 6 कम 6, 6 पंजे 30. So n is equal to 15. So the 15 fringes shifted, right? The central bright fringe will shift it to the 15 beta. This is the CBF, new position. Copy this. Although I have given you the figure, initially the central bright fringe is over here, suppose, right? This is the CBF. Without this, so when it shifted, so what is the distance? What is the distance? d/d mu minus 1. Suppose it is 20 centimeter. Are you getting or not? Is it clear or not? So these are the D1, B1, D2, B2 before shifting, right? These were the shift. Suppose this is D1 now, this is D2 now, this is the D3 now. Is it clear or not? So now this D1 shifted to this D1 comes this is the B. So why to multiply 2? You tell.
I thought like they are pasting it on both sides, so both sides will.
No. This is the thing. Just shift it to this thing. Suppose these are the 1, 2, 3, 4, 5, 6. Suppose these are the 6 beta. So now this 6 beta is shifted. So how many fringes are crossing the center? Only 6. Are you getting or not? So in this question, this is the YDSE experiment, suppose, right? This is the S1 and S2. The wavelength we are using 6300 angstrom. All right. Is it clear or not? So if this is the S1 and S2, this is the central bright fringe. When this is placed in the liquid, are you getting or not? So now the wavelength I have to take the lambda by mu. Is it clear or not? So what is the fringe width? Beta dash is equal to d lambda over d. So what is the d? It is 4/3 meter, 1.33, and d lambda upon mu into d. What is the d? 4/3. What is the lambda? The lambda is 6300 into 10 to the power minus 10. The mu, refractive index, is also equal to 1.33. It is 4 by 3. 4 by 3 into the separation is 1 millimeter. The distance is 1 millimeter. 1 into 10 to the power minus 3. So what is the answer? It will cancel out 6.3. 6 point. This is 6300. Right. 10 to the power minus 7. Right. And this is 0.63 millimeter is the fringe width in this case. Copy this. So this is the fringe width beta dash, right? Now what is the B part? Can you read the B part? What is the B part?
One of the slits of the apparatus is covered by a thin glass sheet of refractive index 4.5. Find the smallest thickness of the sheet to bring the adjacent minima on the axis.
Right. That is the thing. So find the smallest thickness of the sheet to bring the adjacent minima on the axis. Listen one more thing. Initially when the liquid is filled, it will be the central bright fringe, it will be the D1, it will be the D2. Are you getting or not? Right. So if we have to put, listen, we have to put, this is the D upon D mu minus 1. Hello? Yes, Sanjay. If this is the D1, right, this is the D1 this side. So when you put a glass slab, what would happen? Tell me. This fringes will be starting shifting over here. So what to do? We have to shift in this way that the central bright fringe comes over there and the D1 come this side. Do you understand or not? This is the central bright fringe. Is it clear? So what they are in the question they are asking that find the smallest thickness of the sheet. This thickness we have to find so that so that the adjacent minima. This is the adjacent minima, right? Adjacent minima. So if this is the adjacent minima, it is shifted to the axis. This is the axis. Do you understand or not? So what does it mean? What is the shift? The shift equal to beta dash by 2. Understood or not? What is the shift? Only the D1 should shift it to this central bright fringe. Right. So what is the shift? The shift is nothing but D upon D mu minus 1 into T. It must be equal to beta dash upon 2. Right. Beta dash, this is the beta dash. Also listen one more thing. Here the refractive index. Whose refractive index is this? The refractive index of this glass slab. Are you getting or not? Right. Listen one more thing. This is the refractive index of, this is the 1.33 the refractive index of the liquid, and the refractive index of glass slab is 1.53. Are you getting or not? So this refractive index, you have to take the relative refractive index. You must take care of this. Are you getting or not? If it is placed in a liquid, the refractive index is D upon D, refractive index of glass, refractive index of liquid minus 1 into T is equal to, although we have found the beta dash, this is equal to D upon D lambda. What is the beta? 1 by 2 D lambda over D. Is it clear or not? But this is the lambda dash. So we have to take lambda by mu. So D by D, it will cancel out. So mu G upon mu L minus 1 into T is equal to lambda upon 2 mu. Is it clear or not? Right? Sanjay, not getting. And this is the refractive index of what? You tell. Liquid or glass? Liquid. So the thickness you can find lambda once mu G minus mu L upon mu L into T is equal to lambda upon 2 mu L. So mu L will cancel out. Thickness it will be lambda mu G minus mu L upon 2. Are you getting or not this thing? So the wavelength, what the wavelength is? 6300 into 10 ki power minus 10. The glass refractive index is 1.53 minus 1.33 upon 2. You can simplify it. T is equal to 63 into 10 ki power minus 10. This is 0.2 divided by 2. 0.1. 63 into 10 ki power minus 10. So thickness is 6.3 into 10 ki power minus 13 meter. Right, this is the thickness. Copy this. So in this question, right, the wavelength is what? Say 500 angstrom. Incident or two, the separation between the slit is what? The D is equal to 5 into 10 ki power minus 4 meter. The interference pattern is seen on the screen. The D is 1 meter. All right. The thin glass slab and refractive index plate between. This is the thin glass slab. The thickness is 1.5 into 10 to the power minus 6 meter. And the refractive index is 1.5. Are you getting or not? Find the intensity. So when you will place the glass slab, are you getting or not? So this central bite fringe over shifted to this point. Here the intensity you have to find. Are you getting or not? Assume the intensity is I0 and I0 of both the sources S1 and S2. Are you getting? Here the intensity at the center you have to find. This is the question. Okay. So here we have to find the intensity. What is, if this is the I0, this is the I0, all the formula of the resultant intensity is I0 plus 2 root I0, I0 cos delta phi. Right, in the short we can write 4 I0, right, cos square delta phi by 2. This is the resultant intensity. Is it clear or not? Right. So when the two waves are reaching there, although the central bite fringe is shifted there, it is not our concern here. Just we have to find the resultant intensity. So the two waves are traveling and reaching over there. Are you getting or not? So can you find the path difference? Yes. Listen one thing, Sanjay. If the nothing was there, what was the path difference at the center? Say 0. Is it clear or not? If the path difference is 0, the phase difference is 0, the resultant intensity was, say if this is I0, this is I0, the resultant intensity was the maximum is equal to 4 I0. Is it clear or not? But when you place a glass slab in front of this, the path difference will be 0 or not, you tell? No. So can you find the path difference? Yes, I can find the path difference. How to find the path difference? This is, suppose this is the x2, this is the x1. So this is the x2 minus x1. Listen, the x1 minus t, this distance is x1 minus t in the air. This is in the air. And what is the path travel in the glass slab? If this is the thickness t, so the mu t is the one more path difference. Do you understand this or not? Is it clear? So it means this is the path, more path. This is the less path. So what to do? The path difference, this is the more path, x1 minus t plus mu into t is the path travel by the first wave. This is the first wave, this is the second wave. This is the path difference covered. Are you getting or not? Minus, this is the x2. Are you getting or not? So x1 minus t plus mu t minus x2, but x1 and x2 are same. For this position, x1 and x2 same. So x1 and x2 are same, they will cancel out. So mu t minus t is equal to mu minus 1 into t is the path difference. Is it clear or not? You tell. Right. So now the path difference once you found, so you have to calculate the value. This is the 1.5 minus 1. The thickness is 1.5 into 10 ki power minus 6. 0.5 into 1.5 into 10 ki power minus 6. Is it clear or not? So 15 पंजे 75, 0.75 into 10 की power minus 6. This is the path difference. If this is the path difference, what is the phase difference? Delta phi is equal to 2 pi by lambda into delta x. So this is 2 pi. What is the wavelength? 500 angstrom minus 10. The path difference is 0.75 into 10 की power minus 6. Yes, calculate this value. Copy this and calculate this. So this is the 3 pi. Delta phi is 3 phi. So then what is the resultant intensity over here? We can put in this expression is equal to 4 I naught and cos squared 3 pi by 2. I think you understand this is the 0, right? So the resultant intensity in this case, it will be 0. Copy this. Listen. This is the first wave, right? And this is the first wave. When nothing was there, what is the path? Say x. What is the path? Say x. X minus x, it was 0. Are you getting? But when the glass slab is put, what is the path travel in the air? Say x minus t. This is the path travel in the air. But this is the light is traveling in the some glass material. So although its geometrical path is t, but its equivalent path, optical path is mu t. So we take the optical path mu t also. So this is the path travel in the air, this is the path travel in the glass by the first wave, and minus this is the second wave path travel all the in the air, so it is x. So x minus t plus mu t minus x. So mu t minus t is the path difference. Yes, now you ask your doubt. What is your doubt? Right. Yes, clear. Copy this. So few more questions. Okay. So few more questions we can do. But before that, the concept I am teaching. All right. Although it is a very big chapter, but everything is not included in the NEET examination, right? So I'm skipping that. Otherwise, it is a very big chapter. I'm giving you the basic thing. In that case, just revising the class 11th concept. If this is the two sounds wave or the two sources of light placing at distance 3 lambda, right? This is the S1, this is the S2. Are you getting or not? So if this is S1 and S2, one person is moving from infinity to in this direction minus infinity. How many maxima? How many maxima and minima they will found, right? He will find. This is the question. When it is moving on this straight line path, copy this. The question is then the person is moving from left to right, how many maxima minima will you find, right? For example, if this is the source, if you consider this is the point, so one wave is reaching from here, the another wave is reaching from here. So if this is the x2 and this is the x1, are you getting or not? So what is the path difference? Path difference is nothing but delta x2 is equal to x2 minus x1. Is it clear? This is the path difference. If this path difference any point is equal to n lambda, then maxima. And are you getting or not? And if this path difference is 2n minus 1 into lambda by 2, then we will get the minima. Are you getting or not? Sanjay, this type of question we have done in class 11th or not? Yes, you forgot, I think, but we did. So if this is the point, if you are standing just near to the source S2, the one wave coming from the S1 like this, and the other wave is S2. So what is the path difference? This is the 3 lambda minus 0. Do you understand or not? What is the path difference? 3 lambda. So here the maxima or minima you will get. When the path difference is 0, lambda, 2 lambda, 3 lambda, what will you get? Maxima. And when the path difference is what? Lambda by 2, 3 lambda by 2 and so on. What you get? Minima. So if the path difference is 3 lambda, you tell. If you consider the infinity distance, the light is coming from here and coming from here. What is the path difference at infinity? Approximately it is tending to 0. Are you getting or not? So as it is, the person is moving, the path difference is increasing or decreasing? Increasing. So it is the maximum over here. So there will be the point somewhere, right, from between this and infinity, where the path difference will be reached to the 2 lambda, and there will be the point where the path difference is what? Lambda. So this is the point of the maxima, this is the point of the maxima, this is the point of the maxima. Is it clear or not? We will not consider the infinite because we can never roam the infinite. So in the same way, there will be the path difference 2 lambda. Here the path difference is 2 lambda. Are you getting or not? Lambda it is. So it is maxima and it is maxima. Is it clear or not? We are not considering the infinite distance, which is not possible. So how many maxima you are getting in this question, you tell? 1, 2, 3, 4, 5. So maxima is 5. Now we try to find the minima. Are you getting or not? So this is the 3 lambda and 2 lambda between here. The path difference will be equal to 5 lambda by 2. And you will get the minima, because when it is the person is coming, the path difference is increasing. If it is moving this side, it is decreasing. 5 lambda by 2, then 2 lambda, then it is lambda, then somewhere it is lambda by 2. So this is the minima, this is the minima, this is the minima. So the 3 minima on the left side, and this is the 5 lambda by 2, 3 lambda by 2, and this is lambda by 2. Minima, minima, minima. How many minima you will get? 6. Copy this. So this is the one question. Any doubt you want to ask here? Very nice, very nice. In the same way, listen one more thing. If we have a circle and the two sources are placed, this is the S1 and S2. Are you getting or not? So the 4 lambda, right? 4 lambda is the path difference between S1 and S2, and a person is moving along the circumference. So how many maxima and minima he will observe? Person will observe, right? Person will observe. Is it clear or not? So when you consider this the point, what is the path difference at this point when the wave are reaching? 4 lambda. And what is the path difference at this point when they are reaching? 0. So when it is moving in this way, so it becomes 3 lambda, then it becomes 2 lambda, and it becomes lambda. Then it is moving, the path difference is increasing, and it becomes 4 lambda. It is 3 lambda, 2 lambda, lambda, 0, lambda, 2 lambda, 3 lambda, and it becomes 4. Are you getting or not? So how many maxima he will observe? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So the maxima is 15, 16. Now how many minima? This is lambda by 2, 3 lambda by 2. Sorry, this is 3.5 lambda, 2.5 lambda, 1.5 lambda, and this is lambda. So 4 maxima this side, 4 plus 4 plus 4 plus 4. Again the 16 minima you will get. Minima you are getting. So this is the solution.